Hello, geometry students. Welcome to lesson 10.3, areas of regular polygons. Just want you to remember that a regular polygon, first of all, a polygon is a closed figure made of straight sides, right? And we're talking about regular polygons, so that means that all angles are congruent and all sides congruent. So like a regular quadrilateral would be a square, and a regular triangle would be an equilateral triangle. So we're now going on to, because we've already did like parallelograms, trapezoids, rhombuses, and kites, those four-sided figures, and we've already talked about areas of triangles, of three-sided figures. We're now going into regular polygons, so meaning five or more sides, okay? And all the sides and angles are congruent. All right, so we're going to be talking about, we're going to need to use the radius of a regular polygon and the apothem, which is a word that I was not familiar with before. But when we're finding the areas of these regular polygons, what we need to do is we need to pretend that we're putting a circle around the outside of it, okay? So that we could use the radius of the circle to help us do our calculations. So it says you can circumscribe a circle about any regular polygon. Okay, the center of the polygon is the center of the circumscribed circle. Okay, so the radius is the distance from the center to a vertex. Okay, so here's the center. The vertex are these corners. Okay, so here we have a 1, 2, 3. Here we have a regular hexagon. Okay, regular hexagon. And so the radius is from the center to a vertex. So remember that center is also the center of the circle. The apothem is perpendicular, so meaning it makes a right angle, perpendicular. Okay, it is the perpendicular distance from center to a side of the polygon. Okay, and so we refer to the apothem as A, and usually the radius is R, lowercase r. So let's also put some labels in here. First of all, this line here is pointing into the center. Okay, this line here is pointing here, so that is the radius, halfway across the circle, half of the diameter. And this line here that connects to the side perpendicular, that is the apothem. Okay, so you have center in the middle. The radius goes all the way to the outside vertex, which also connects to the outside of the circle. And the apothem connects from the center to a side of the polygon. So the apothem does not go to the outside of the circle. All right, so here it says the figure at the right is a regular pentagon. Okay, regular meaning all these five sides are congruent to each other. And then with radii and apothem drawn. So the radii, what it does is you'll notice that they're splitting them into equal triangles because we have a radius here, 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 right? So these are, you'll notice there are 5 equal triangles in there. congruent triangles. Okay, well, because we could sketch a circle around the outside of this, and a circle is 360 degrees, okay, what we could do is to find angle 1, we can divide 360 divided by 5, because we split it into 5 equal angles inside, and we get 72 degrees for the measure of angle 1. Okay, so 360, because the circle is 360 degrees, and we split it up into 5 equal parts. All right, then we need to find angle 2. Okay, angle 2 is inside of here. Okay, it's that we have like a little triangle inside of there. So angle 2 is half. Okay, so angle 2 is half of the measure of angle 1. Oops, measure of angle 1. The reason why is because the apothem bisects vertex angle. Okay. So the vertex of this triangle here. So that means it's 1/2 of measure of angle 1, 1/2 of 72. That is 36 degrees is equal to the measure of angle 2. Now we just need to find the measure of angle 3. So I'm going to just redraw this. Okay, so here we have 90. Here we have 36. And now angle 3 is right there. So we know that all angles in a triangle add up to 180 degrees. So we can do 180 minus the sum of 90 plus 36. We get 54 degrees is equal to the measure of angle 3. Okay, so first we started by just dividing 360 by the number of triangles we had, or the number of angles here we have inside. And so that was 5 angles inside. So that's 72 degrees for angle 1. Then we split 72 in half to get angle 2. And then we subtracted from 180 to get angle 3. Okay. So it says, suppose you have a regular n-gon. So that means a polygon with n amount of sides with side s. So s is the length of each side. The radii divide the figure into n congruent isosceles triangles. So up here we had 5 congruent isosceles triangles. Each isosceles triangle has areas, this should be area, equal to 1/2 of the apothem times the length of the side. Since there are n congruent triangles, so in this case there's like 5 congruent triangles, the area of the n-gon would be the number of triangles times the area of each triangle. The perimeter of the n-gon is, well, we would have to take side times however many sides there are. So the number of sides times the length of the side. So then if we substitute P, okay, so look, N and S. So right here is N and S. So if we took N and S out and substitute that with P, you get the area is 1/2 of the apothem times the perimeter, okay, where P is equal to N times S, the number of sides times the length of the side. All right, so we can also put that up here in our formula sheet. Okay, the area is equal to 1/2 the apothem times the perimeter, where P is equal to N times S. All right. So we have decagon, that's 10 sides. Okay, so let's plug in our formula. 1/2 times apothem times perimeter, where perimeter is N times S. All right, so I have a decagon, so that's 10 times length of each side, which is 8. Okay, so I have 1/2, the apothem is 12.3, and my perimeter is 80. Plug that into a calculator. You get area is 492 inches squared. And that is your area, 492 inches squared. Down here, says some boats used for racing have bodies made of a honeycomb of a regular hexagonal, so hexagonal 6, prisms sandwiched between 2 layers of outer material. At the right is the end of one hexagonal cell. Find its area. All right, well, first of all, we need to find the apothem, which it looks like it is a 30, 60, 90. Okay, so use 30, 60, 90 rules to find A. Well, it looks like the short leg is 5, so the long leg would be 5 square root of 3. All right, so now we are going to plug it into our formula, 1/2 apothem times perimeter, where perimeter is N number of sides times the length of a side. Well, it's a hexagon, so it's 6 sides times 10 each. So we have 1/2 of 5 square root of 3 times 60. All right, I know that 1/2 of 60 is 30. So I have 30 times 5 square root of 3. 30 times 5 is 150 square root of 3, which then if I plug that into the calculator, it comes out to about 260 millimeters squared for the area of one of these hexagonal pieces. All right, so some new things in here, especially with the apothem. Okay, remember the distance from center to a side. So it's a matter of really paying attention to these formulas. And again, we're still using those 30, 60, 90 and 45, 45, 90 rules. That is the end of lesson 10.3 on areas of regular polygons.